So here DFT property, that is nothing but circular convolution property. Circular convolution property, and it is also multiplication of two DFTs. Right. So now here statement, if x1 of n has a endpoint DFT, that is x1 of k, and x2 of n has a endpoint DFT, x2 of k, then x1 of n circular convolution symbol x2 of n has the endpoint DFT, that is x1 of k into x2 of k. Okay, so here what is this circular convolution between two sequences equation? So now here that is nothing but summation x1 of, take the variable here, that is m variable, the resultant one is here x3 of m, consider like that, x1 of n, then x2 of m minus n, modulo of n, x1 of n, x2 of m minus n, modulo of n. Here n is from 0 to n minus 1. So this is the circular convolution definition. Now here proof. So okay, here to prove this, here I am taking here IDFT formula, right? So now that is nothing but IDFT of, I am taking directly here x1 of k into x2 of k. Okay, now that is nothing but 1 by n summation, here is the sequence is x1 of k into x2 of k. Here k is from 0 to n minus 1. Here e power plus j 2 pi by n kn. So of course you know that what is x1 of n, that is the x1 of k, that is the DFT of x1 of n, and what is the x2 of k, that is the DFT of x2 of n. So now here this is equal to, okay, so take those formulas, summation k0 to n minus 1. What is x1 of k? That is the DFT of x1 of n. So what is that? This is the formula further. So I am writing that formula. Right, now for x2, right, and now here is a third term. What is that? E power j 2 pi by n kn. Okay, here 3 summations, right? So 2 for n, 1 for k, and 3 exponential factors. Okay, so now here smartly I just club all these like this. Look here, 1 by n. Now summation n0 to n minus 1. I am taking this one, so outside. So now x1 of n x1 of n. Now here I am using here, to avoid the confusion, another variable in the place of n for this summation. What is that? P. Okay, right. So now x1 of n, this one is outside. Now summation p0 to n minus 1. Now x2 of p, then another summation. What is that? K, 0 to n minus 1. And now what is what are the left terms here? These terms, right? So now combine all this, and then I am writing like this, j2 pi k. So common. Now here is a, what is that here? Here I am using this one as IDFT of x1 of k, x2 of k is nothing but, for simplicity, this is nothing but x3 of m variable, not n variable. Okay, that's why here use the symbol m, here also use the symbol m. Okay, right. So now this is nothing but, what is that? x3 of m, right? Already we wrote like that definition also. So okay, that's why here. So here see this IDFT of x1 of k, x2 of k is nothing but x3 of m. That's why here the resultant one summation, here exponential term, here one n variable is there, but here that is nothing but m variable. So use the m variable here. Okay, so it's okay. Now e power j2 pi k common. Now m is here. The next one is minus n. Next one is minus p divided by n. Divided by n. Okay. So now the next one is nothing but x3 of m is equal to, so here is 1 by n summation, I am repeating this one, x1 of n summation p 0 to n minus 1, x2 of p, e power another summation is there, summation k 0 to n minus 1, e power j2 pi k m minus n minus p divided by n. Now this here, so I am using the formula. What is that? We know that basic summation formula, summation a power k, where k 0 to n minus 1 is nothing but 1 minus a power n by 1 minus a. Here if a is not equal to 1, this is the answer. If a is equal to 1, so apply LH rule and then you can get the value like this, n. So I am using this formula here. So this is nothing but, here take this summation, right? The summation is nothing but, so here summation k 0 to n minus 1 e power j2 pi m minus n minus p divided by n whole power k. That means now this is nothing but a. So this is equal to, what is that? 1 minus here e power j 2 pi m minus n minus p by n in power n, right? So power n, this whole power n. Now 1 minus e power j 2 pi m minus n minus p by n. So here in this case this one is not equal to 1. So now this is equal to, if you see, e power j 2 pi m minus n minus p, and this is an integer value. Now 1 minus 1, so divided by anything. So now this is equal to, what is that? So same thing here. So 1 minus 1, 0 by anything is nothing but 0. So that means here the first case, so here a is not equal to 1 case. So this is 0. But so now if a is equal to 1, so a is equal to 1 means here the value is 1. But so a is equal to 1 means e power j 2 pi m minus n minus p by n should be equal to 1. Okay, it should be equal to 1. So here it is equal to 1. It is equal to 1. So when and only, right, this m minus n minus p is an integer multiple of n. Am I correct? Is an integer multiple of n. So that means here I am writing here m minus n minus p is an integer multiple of n. Okay, so that means here that is equal to 0 for a is not equal to 1. N a is equal to 1 means, so here what is the condition here? M minus what is the condition here? M minus n minus p is a multiple of n, right? And of course if you observe this one, what is the a here? E power j 2 pi k m minus n minus p by n. Am I correct? So now here when this one is equal to 1, so it is an integer multiple of n. So that means if p is a, see here, if p is a, m minus n plus l into n, right? If p is a, m minus n plus l into n. So see here, m minus n plus l into n. Now m minus n and this m minus n gets cancelled, and then you can get L into n. Then L into n divided by n means n cancel, then e power j 2 pi k into L, then always it is equal to 1. So now here the condition is p is nothing but m minus n plus ln, where L is an integer. L is an integer. So now here this one is also rewritten like this. So what is that? M minus n modulo n. Am I correct? P m minus n modulo n. We may write like this. So now here coming to the x3 of m formula, here is a 1 by n summation n0 to n minus 1 x1 of n summation p0 to n minus 1 x2 of p into the remaining 1 summation of 1 so and so is equal to n when p is equal to m minus n modulo n. Now here these two here gets cancelled. So here n0 to n minus 1 x1 of n summation x2 of p is nothing but m minus n modulo n. Here limits for n is nothing but so 0 to n minus 1. So actually you can get the limits for n as like m plus ln to m plus ln minus of n minus 1, like that, if you substitute based on this formula. So then here the range or number of samples are n samples, that's why you may take 0 to n minus 1. Okay, so now this is nothing but x3 of m is nothing but, what is that, summation n0 to n minus 1. Now x1 of n, x2 of m minus n modulo n. So okay, so that means here x1 of n, this is nothing but circular convolution with x2 of n, hence proved. Okay, right? So that means here what is this? This is the DFT of x1 of k into x2 of k, which is equal to circular convolution between two sequences. Okay, thank you.